and welcome back to another Lair Belair, the live edition. Welcome everybody. Today's Wednesday. What's the date? March? No, it's April 20th, 2016. Anyway, live streaming today. Wanted to do a quick stream on Raspberry Pi case. This is sort of a collaborative project with Kirby G. He's in the chat room. Say hello to Kirby. And let's take a look here at stuff on my screen. There you go. So I'm in the chat room. Everybody's coming in the chat room. That's awesome. Everybody say hello. And this is really cool. So Kirby started working on a new Raspberry Pi case, sort of inspired by the Raspberry Pi B Plus case that I made, I think a year ago. And it was sort of like a Domo Kawi style Raspberry Pi case. You guys may have seen it. It's on our Adafruit page. Probably should have had it loaded, but I don't. But here's what he put together. This is just checking the audio. Audio looks okay. Okay. So here's the Raspberry Pi case. It's like a three-piece design. It's got like little teeth, it's got a little face, and it fits the Raspberry Pi Zero. So the cool thing about Fusion, so this was modeled in Fusion 360. It's from Autodesk. It's free software that you guys can check out. The cool thing is when you do a public share of a file, you get this cool little preview of the file. So you can step through it, you can explode it like such, and that's just a crazy explosion. I'll talk about the Raspberry Pi model in a second here, but it's a really nice way to inspect your stuff. You can do section analysis right within the browser, and this is sort of Autodesk's UI that they have on their website. It's sort of free with your account, and you can really analyze stuff when you share it. So this is a shared file, and if you look at the top right, you have a download button. And there's so many different file formats. So a Fusion 360 archive will retain all of the features, history, all the things, all the parametric stuff that's in the file is in there, so you can download that as a file. Inventor 2014, IGS, SAT, STEP, DXF, STL, which is kind of like counterintuitive because it's like a merged thing. All the rest of them are sort of like the original solids, so you can use those in any type of app that supports them. And then they just added SketchUp. So there's a new update to Fusion that just came out a couple days ago, I believe. And they have a new logo, so that's how you know it's new. And SketchUp is interesting because a lot of people use SketchUp, and this is a cool way to sort of get files out and into SketchUp if you so like to do that. So anyway, let's take a look at this this Raspberry Pi model. So Kirby found this on GrabCAD, which is a lot like Thingiverse, but they're like legacy. They've been around for a while. I don't actually have an account with them, but you can download stuff for free, so that's what I did here. So this gentleman here, Tom and Appy, modeled this super intricate Raspberry Pi model. I'm not sure what he designed it in, but nonetheless, it is a phenomenal model. So if you guys want to use this, I guess he made it in SolidWorks, maybe, yeah. You can download the file and import it into your projects if you want to use it, and yeah, and these are actually the Adafruit photos right here. It's awesome that he used those, but it looks great. The render looks great, and as you saw in the model here, let me turn off section analysis. I wonder if I can hide stuff. Yeah, you can. Hide selected. Hide selected. This thing's super intricate. Like every little resistor is modeled in there. So I went ahead already and downloaded the file and brought it into Fusion and took a look at it. So if you want to do that, you can't actually open files. You have to upload it. So you click this little button here in your data panel. Click on the little upload cloud button, and then you can upload it to whatever project, whatever folder. You can change the destination using that button there. And you just select the file and upload it. It takes like a second. So I have it here. So like I was saying, since it is a Fusion 360 archive, all of his history, all of his features that he made along the way are here. So they're fully editable. Munch editable. And yeah, so all his sketches are right here. Those are all the sketches that pertain to the project. All the bodies, of course, are there. And just take a look here of the craziness of this model. I really don't ever go this far as to model my components. Like, this is crazy. Every little resistor is modeled. So huge shout out to Tom too for making this model and making it public. So check that out, man. It even has the part numbers here. It's like so much geometry here that I think my computer's not as fast as it should be. But anyway, it's a good model. Oh, it's because I'm streaming, that's why. So when I stream, you know, processor, whatever. So anyway, I wanted to step through the file, kind of show it to you guys, and then do a little bit of edits here to it. So it is a two-piece design. It's using that sort of snap fit clip thing that I showed you guys on the last week's layer by layer, so that you can see in the lip it has those indents, and then it has these sort of extrusions so that the top part can snap into it. So you can see this has these little corner nubs. Let me hide the pie for a second. You can see the corner nubs here, these little triangle dealies. And it's the cool thing about this case is that there's no screws necessary for it. Let me turn on the section analysis so you can see through it. The standoff here has a little peg, and that goes into the mounting hole of the pie, and then the peg itself actually snap fits into this taller standoff, so the whole thing is snap fit, and it's going to be like really nice. So that's how that's working, and it pretty much is a simple case. Kirby still has some things he wants to do to it, but he did give me early access to it, so I can modify it and do a little bit of show and tell on it. So the first thing I wanted to take a look at was if I look at just the bottom side, you can see that there's a little bridge, and it's really thin. So that might be a problem when 3D printing it. It's really thin, so it might break off, or it might have like a problem depending on what material you're using. Like maybe this would do okay with PLA, but it might be it might have a little issue with ABS or PLA PHA. And then I noticed here that in the opening for the HDMI port, there's actually a little cutout here on the bottom surface. You can see there's a little overhang of the standoff, so the standoff is kind of floating a little bit. So we're gonna try to fix that, and I wanted to show you guys how sort of easy it is to leverage all of the features that are already here and just modify a couple things. So I think that's it there. Yeah. So let's do like the first thing. So the first thing is I actually already printed it out as it is, and it actually is a little bit too tight because I did some edits of my own to it already. So here's the Pi Zero, and here's the case that I printed. This is the bottom half of the little happy face. Hi, how you doing? And it doesn't fit because we have to take in consideration, I actually made it a little bit smaller, a little bit shorter, and because of that, it's hard to fit it in because these nubs are actually in the way, so I can't get it in there. So we're gonna update that. And another thing is, like, since I shortened it, I wanted the portholes to be closer to the actual ports, and because of that, there's nubs, right? So these little nubs here, so you can't insert it at an angle and get it in the nubs and get it to pass through the lip, so it's just too tight. So it's always a good thing to have extra sort of wiggle room, right, around the board, because the board is too tight and I can't get it in there. So, but that's the whole point about 3D printing and rapidly prototyping, is that to do iterations. Rarely do you ever design one thing and then it works. It's like winning the maker lottery. It is possible, but it's like the odds are against you. Okay, so I'm gonna jump into that, but I want to take a look at the chat room because chat room's fun. Everybody saying hello? Okay, cool. And yeah, oopsies, forgot the chamfer near the HDMI like you mentioned. Yeah, I'm gonna add chamfers and stuff. We'll show people how to do that. Bluetooth doesn't work on Pi 3 with Pi TFT. Yeah. This is a new Pi PC. This is the Raspberry Pi. Yeah, the Raspberry Pi Zero is a $5 thing. It's elusive because like nobody has it in stock because they're so popular. But yeah, they're $5, and it's a very powerful little piece of kit here. Okay, well, that's the Pi Zero. Okay, cool. Just making sure the chat's all happy and stuff. So let's jump back into CAD stuff because that's what we're gonna do. Let me flip my script. There we go. Alright, so let's see. The first thing I want to do is like make it a little bit wider. So if you look on the top view, you can see these nubs are indeed a little bit past the board. So we just need to do a little offset or just modify a sketch or whatever. There's so many different ways to do it. I'm just going to do it with an offset. So in the timeline in the bottom here, I really got to shrink my face because like I need to work with the timeline. So give me a second to do that, guys. I'm gonna make my face a little bit smaller and then put it like right there. Yeah, I'm using Wirecast, by the way. If you guys are curious of what the broadcasting software I'm using, it's Wirecast. So what I did, I just moved my face so I'm not, in front of the so you can see all the UI stuff while I work. Alright, so I'm going to step all the way back so you can step through the timeline of all the features that you've created in the design. So I'm going to step all the way back, and I'm going to incrementally move until I get to a spot where I think I can do it. So I think I'm right here. So this is where Kirby created the main shape, and then he made some fillets, and then right here is where he makes a plane. He cuts it in half and does a shell and goes to town on it. So what I'm going to do is right before that split, or plane really, I'm going to do some offsets on these surfaces. So to do that, I'm going to hit Q on my keyboard, but you can do that by doing this right here, press and pull. And I'm going to press and pull these guys all the way around. I don't have to select the corners because Fusion is smart enough to know how to modify. And I'm going to put negative 0.4 of a millimeter. And you can see if I hold down Command or Control on PC, I can preview what it was before. So that's the negative 0.4 I'm going to do in the offset. So I'll hit OK. So now if I click on this button over here, move all the way to the end, I can look on the top view again and see if there's enough wiggle room. And I got a little bit of errors. I got an error here on this chamfer and whatnot, but we'll cover those in a second here. So that didn't work too well, did it? The offset didn't seem to either take effect or it wasn't enough, but it looks the same to me. So let's go back here. Oh, I put negative. I'm sorry, I'm supposed to put positive. Derp derp. Alright, so we're pulling it out, not inward, so that's why it should be positive. So hit OK. And then since I was in the front anyway and I double clicked on the timeline here, it should just carry over. Alright, so excellent. Everything, I have a little bit of extra wiggle room here, and that's fine because sometimes the board is a little bit bigger because the fiberglass or whatever, the FR4 or something board has a little bit of extra material. When it breaks off, they have that little bit of extra material. And it's good to have wiggle room. So all the way around, I have just a little bit of a clearance so that it should be able to just fall right into place. So that's good. So that's the first thing. That was easy to do, other than the negative thing. Then I should have put positive. Derp derp. Another thing I want to do is I actually want to make these ports smaller. These ports are really conservative. They're really huge. And a lot of the time, micro USB ports and any type of port has this massive connector. Like the outerness of the connector is like super massive. Point and take. Point here. Like if you see this guy, you can see the port is freaking huge as compared to the actual connector, the metal connector. So that's a good and conservative, but since the board is so close to the edge, I think we can get away with making it a little bit smaller. So that's what I'm going to do. I'm going to make it a little bit smaller. And of course I still need to fix this part here where the standoff is like a little floaty. So I need to kind of fix that. So in the timeline, I can look at right where that happened, and it's about right here. So I can just probably click on all the way back, and then there's this little playhead. You can scrub through it, click and drag the playhead just to about where the things happened, where these cutouts happen. And one thing I just learned about it, if you click on a feature in your timeline, you can right click on it and say suppress features. And what that means is, suppress means like don't do or disable, and that basically just disables it from ever happening. So it's a cool way to keep it there but not delete it. And I'm having that weird chamfer problem again where it's like, hey, I have a chamfer problem. You see the little red thing indicates that there's an error. and I don't know what the error is, but if we double click on it, it'll tell you what the deal is, and it's saying what does the little message say? It says that could not be created, request aside, might be occurring. Yeah, it's like saying that there's not enough material or geometry to properly do it. So I'm thinking it's the top piece. Yeah, it's this top piece here. So let me hide the pie and try to alleviate this error. Yeah, so instead of 1, let's see if we can trick it and say 0.99 of a millimeter. Yeah, so 0.99 does a better job than 1. I don't know why, but it's just sort of hit OK on that and just put 99, and it's pretty close to 1 millimeter. So there you go. Okay, that looks fine. Now that we got that cleared out, I want to get back to adding new ports. So if I bring up the Raspberry Pi, what I tend to do is I like to project a surface of my port and then offset it so I can create a port from that actual port, right? So you can see the HDMI has a surface here, and to do a projection basically says like I want to make that into a sketch, and then you can use that sketch to like either create new geometry or take away geometry. So I'm just gonna hit P on my keyboard. It's also up here in the sketch thing, and it's P is the shortcut, and that creates a copy of the sketch. So that's all good. I'll hit OK, and then I'll create an offset of the outline here, and if I click on that outline, I'll just type in 1 millimeter, or not. I have to. Sometimes the little floaty window doesn't work, so I guess that's why they have this one too. Over here on the right, you see the little panel, so I'll hit 1, and then that looks a little bit much. I'm gonna actually make that half, not over there, over here. I want to make the same mistake, and I'll just put 0.5 and I'll hit OK, and then I'll hit Stop Sketch. So I'm going to use this sketch to cut out of the 2 halves of the case. So let me hide the pie. I'll hit E on my keyboard or click on the extrude thing up here next to create, and I'll just click on these on several of these like things, and I'll just start dragging it out. And then if I bring back the top and the bottom, you'll see it instantly turns the operation into a cut, and that's exactly what we want. And I'll just make sure that it's not cutting the standoffs, which it's not, so that's good. So now I can hit OK, and now you can see that it's a nice cutout for the HDMI port. There's a little bit of offset, which is good, and that's pretty much it for the HDMI port. And then of course, if you look at the bottom half and hide that, you can see the standoff it has is no longer floating, and that's all good. So that's all good. The next stuff is a little bit more different. I was gonna say challenging, but it's not. So if I bring back the Raspberry Pi, and then I look at the USB ports, I actually can't do a projection because the USB port has these little flanges and stuff. If you look at any micro USB port, it has these little flanges and stuff, and that's really nice and detailed, but it's kind of a pain to be able to like to project a sketch of it, because I kind of can't. I only have these flat surfaces. So what I'm going to end up doing is I'm just going to draw around here with a rectangle. So what I'll do is I'll click on the 2-point rectangle tool, and then I'll click on this sort of canvas, which will be this front plane, and it'll let me sketch on top of it. So I'm just going to zoom in, and then my grid gets a little bit more detailed, so I can just start clicking and drawing it out. So I'm just going to use my best judgment to make an offset of my own. So I can see that like there's two check boxes, or there's 2 grid units here to the left, to the top, and there's probably 3, and then the bottom I have now I have 2. So that looks okay. And I'll probably bring this in by 1 little box here like that, and it'll snap there. I don't have to hold anything down, it just likes to snap by default. And that looks good to me. And then if I want to make another one, instead of drawing it again, I can just use the rectangle pattern under sketch. I'll click on that. I'll select my 4 lines that make up this rectangle, and then I can use these arrows to pull out copies, And you see the default is 3 copies. I only need 2. So, or the quantity is 2. And then I'll pull it out to where I think it looks okay. Probably one more bar right there, and that looks perfect. So now I'll hit OK. And now I have my 2 USB port sketches that I can use to cut out of the case. So I'll do that now. I'll hide the Pi. Just like before, I'll hit E on my keyboard, or hit press, or not press and pull, extrude, which is over here under create. And I can just pull this out like that. And then when I bring back the bottom and the top half, you'll see that it turns it again into a cutting operation, which is just what we want. And just making sure that standoffs are not being cut out. Nope, nothing else is being cut. So hit OK. And now I have my shorter looking port cutouts. Now the next thing we can do is we can do a little bit of fanciness. We can add like fillets to the edges here, to the corners. And when you're doing a fillet, by the way, fillet's up here under modify next to chamfer. Just taking me a second to click on them. You don't have to hold anything special. Like it's Fusion's smart enough to seek behind surfaces. That's too big. Sorry, I meant to put 1. There's my 1. Hit OK. And then that looks nice and rounded off. And the next thing I'll do is I'll add chamfers to these guys of about 1. Yeah, 0.5 looks fine. So that way that the port has a little bit can recess a little bit more inside. And then I'll select these 2 guys here. That looks good. So hit okie dokie. And that looks nice. I think that's about all I'm going to do. Oh, one other thing is if you look at the bottom and the top half, if you look at the thickness of the actual surface, like the bottom of it, you'll see it's 1.5, and that's because the shell just shells around the whole box. I actually want to make it less because that's a little thick. So what I can do is I can hit again. I can make a new offset, or press pull rather. And then I'll put negative over here, negative 0.5 millimeters. And that way it won't take so long to print, and it doesn't really need to be that that thick anyway. And then I'll select the bottom half here too. So it's just pushing it away so it's not so thick. So now it should only be 1 millimeter thick, but the edges will still retain that 1.5 millimeter thickness, which is good. And the standoffs stay in place. So this edge here stayed in place. So everything should be okay. So all the ports should still be where they were. Yep, and they are. And again, that's going to help print faster and stuff. So, one thing I want to do is I actually want to make the pegs a little bit shorter because, oh no, I guess you don't have to. But if you wanted to make the peg shorter, you can again just click on, I wonder where it is here in the timeline. You can either step through it or just keep clicking until you find the thing. But we're gonna skip that part and just leave it as is. So that's pretty much it. At this point, you can export it out and print it. Which if you guys are listening, the printer finished a minute ago, and I'm printing it on my PrinterBot Play using Simplify 3D and Octoprint. And if you guys haven't already, support Gina on Patreon. We have already done that, and a lot of folks of you have, so that is awesome. Octoprint is definitely one of those things that I can't live without. And yeah, things are working out. So here's the finished thing. It's all finished. And I'm going to rip it off the bed now in a second. And let me check the chat real quick, because I have to I think the teeth were done too, so just auto adjust. Oh, that's right. Yeah, I forgot about the teeth. Cool. So Kirby's in here answering a lot of questions, so that's great. Good stuff. And somebody got banned for saying naughty words, so be nice. All right. Let's go back to Octoprint interface, and I'm gonna go ahead and rip this off. Pretty easy. Have my handy dandy tool here. That was simple and painless. Printerbot Play has very, very nice little printer. So let's take a look at overhead and see if we can, if the lighting's all good. Yeah, the lighting's all good. So here's the second version of it. Here's the first one. That's no good. We'll throw that in the recycling bin. I'm hopeful that this works. Alright, so it's a little bit tight still. And I don't want to break the board, so is this really the same? I don't think it is. I must have printed the wrong version. Womp womp. Yeah. Let me double check here. Oh man, it's the same one. Oh well. We can print the new version. So what I'm going to do is I'm going to delete this from Octoprint. And I'm going to show you how to save it out of Autodesk Fusion. So I'll save this bottom half because that's the one that actually has all the ports and stuff. Right click on it, save as STL, and the refinement's at medium because it's a simple case. You could do an output here where you like send it directly to your slicer, but I like to save it out for saving it local purposes. So I'll save it here. Oh, I did do it wrong. I can see here that I did slice the wrong thing. Yeah, you gotta be careful. I was rushing, you know, because I have a live stream and all that, so that's what I'm gonna blame it on. So here's Simplify 3D, which is my favorite slicer. It is paid software, but it's definitely well worth it, as you have so much control and good visualization of your actual path. Did it not save? I guess it's this one, yeah. I saved it in the wrong spot yet again. Let me fix this up real quick. So I'm gonna delete that and bring this over into my STLs folder. So there you go. So there's the latest. I can tell by the date modified. It is 10:56, 7, whatever, a.m. in the Eastern time. And there you go.
Switch over.
Oh, oops, thanks Pedro. Pedro over there helping me out. Yeah, so what I was doing was just exporting out of Fusion. So what I did was I right-clicked on the solid, hit Save STL. I didn't do anything here. I hit OK. I saved it in the right spot, and then I got confused as to which was the newest and which was the oldest one. But anyway, we're here now in Fusion, or in Simplify 3D. It is paid software and all that good stuff. So let's take a look at the process here. My diameters, you know, for all the standard stuff that you're used to, one multiplier, which is like 100%, and Cura. The extrusion width is 0.48. Retraction is a little bit, 1 millimeter retraction speed. My layer height's a little bit lower than 0.2, so it's 0.19. 4 top layers, 4 bottom, 2 perimeters, inside out. First layer height is 100. There's a lot of settings to dig through. So if you guys are more interested in that, I'll probably do I can do a tutorial on just settings because there's too many to look through. But the most common ones are like the infill, your temperature, the print speeds, and this is normally the print speed I go to. This is the printing speed is like the rate of which the material is coming out of the nozzle, 60 millimeters, and this is the rate of the movement. So there's like a feed rate and then a movement travel, so that's 90, and that's pretty much it. I'll hit OK, and then what I really like about Simplify is the toolpath visualization. So you can see here all the layers are all clean, and the infill and the parameters are all looking pretty good. So it looks good. I'm gonna export this out now, or save it as on my disk and put it in Octoprint. I'll just drag and drop it. I'll replace this file here. And it says it's going to take about a half hour and some change, and it's going to take about that much, about 30 cents of material, so not much of a waste there. And again, we can just toss it in the recycling bin browser. So upload, you could drag and drop it, but I'm already here, so that's the right file. Yep. Uploading. What I like to do is home everything before I print, and because it's uploading and saving, it's a little bit laggy right now. Let me bring the chat window over here on my other monitor so I can see what you guys are saying. Cool. Alright, so there it is, homing the Z with the Z probe and stuff. And I'll go ahead and hit print. And what the terminal will show me is all the G-code stuff. What is it actually doing? It is just preparing the heat. It's like pinging the pi and saying how hot are you, and it's saying it's increasing here. This is temperature. T is for temperature, E is for extrusion, W is for weight, like time weight. So it's going to heat up and start printing on its own, and it'll have the countdown and all that good stuff. So there's a little monitor of the temperature. If you guys haven't used Octoprint yet, definitely check it out. It's open source software and it runs off a Raspberry Pi. It can run off of Zero and stuff. Is Simplify better than MakerBot software? Yeah, absolutely. I think it is, definitely. Again, because of all the different settings that you have, the visualization tools, there's a lot. Kirby really needs to try Octoprint. Yes, you do. All right, folks, so if you have any questions, drop them in the chat here. Oh, hey, Caleb. Caleb Kraft is here from Make. What is up, man? He vouches for Simplify as well. Or Cura, if you want to stick with open source free stuff. Cura is also a great option. I use Cura for a good amount of time. Oh, cool. He said he was able to pull off some prints that I had not been able to in Cura and Slicer. Yeah, it has some really advanced sort of slicing techniques where it's a really, really speedy slicer. It slices things super fast. So that's another thing you're paying for. Oh, cool. Megafire had a problem, and we helped him out last week. Yeah, no problem. Or an Octo problem, somebody. Okay. Cool. Thanks, Caleb. So let's take a look at the monitor here. Is it printing? Yeah, it's going to start off in like a couple seconds. There it goes. So the printer rod's going to go to town. It's going to it's going to use the Z probe to calculate the offsets on the board and make sure on the bed and make sure it's leveled out. And it is, and I have an outline set up. I don't even have to look at it. I'm looking at it here, and I have good confidence that it's just going to be okay. And the quality's not the best on my PiCam, but I can adjust that. I haven't done that yet. You can like make the you can adjust the lens to make it more close up. So right now it's doing pretty good though. Man, this is nice and smooth. Cool. Is this Wirecast showing this? Uh-oh. Yeah, it is. Okay, cool. Been like that the whole time. All right. Well, Andre is saying, not sure if I saw this comment, but if you click on the extrude you want to modify, Fusion 360 will mark the operation in the timeline. That is cool. I did not know that. Thank you, Andre, for that tip. I think that's going to be really handy because a lot of the time I'm like digging through and stepping through the timeline to figure out where is that feature. So you can just hover over an extrude. Let's say I wanted to see where this is. I think, yeah, and look, it makes that little marker right there. Those little 3 dashes tells you, hey, that's where the feature is. That is so handy. I've noticed that, but it didn't click. So that is cool. Thank you so much, Andre, for that comment. That's going to save me and hopefully a lot of folks a lot of time when they're like looking for that thing in there, that feature in their timeline. Cool. All right, well, the stream has been going on for a good half an hour, and that's about the designated time that I wanted to do. So again, if you want to check out the Raspberry Pi Zero CAD file, that's available. You might not be able to buy the Pi Zero at any place at this point in time, but there are, I'm sure the foundation, the Raspberry Pi Foundation, is working really hard to make more of these because they sell out everywhere as soon as they're available. But when they are available, you have a couple of different places. Obviously, I'm a fan of Adafruit, so you can get the Zero there if you search for Raspberry Pi. I think that'll work. And we have some packs too, but we also sell it standalone somewhere in here. Maybe I should have just typed in Pi Zero. There it is. Out of stock. I'm so sorry. But if you want to, you can sign up for this thing here. You can sign up to get a notification. Or there's a website, right, guys? Isn't there a website that's like, is Pi Zero in stock or something like that? Is Raspberry Pi Zero in stock? I think there's a website. I don't know where it is. Does anybody know in the chat room? Anyway, you can check that. Of course, Adafruit will have them as soon as we have them. I know that's not helpful, but oh well. What else? Okay, so yep, all this stuff is all the content and things that Adafruit does video-wise is supported by you folks. So if you want to pick up some stuff, there will be a discount code later tonight because there's more shows happening. Did this one. Next up is the Show and Tell show, where people from around the world, makers, hackers, you name it, come on the Show and Tell. It is a Google Hangout. So go to the Adafruit Google Plus page and monitor that until Phil will paste the chat link. In the chat, he'll paste the link, and then you guys can join and show off your projects if you want. Maker spaces, what you're working on, anything like that is all good. Art is welcome as well. So that's happening at 7:30 p.m. Eastern Time. It's a live show, and then shortly after that at 8 p.m. is Ask an Engineer with Lamar and Phil, where they have a full hour of open source, Arduino, Raspberry Pi, new products, and more. So it's like show day here on Wednesdays, and of course that coupon code, as I was saying, so you can save some monies. All right, folks, so that's going to be it for this one. I appreciate you guys for stopping by and contributing in the chat room. It's always fun. But maybe I'll actually show this off on the Show and Tell, if that's cool with Kirby, because I don't have anything else to show off. I already showed everything. But thank you guys so much for the comments. I appreciate you guys for hanging out with me in the morning here. It's still morning. Somewhere it's morning. But that's it, guys. Thank you guys again. I will see you laters. But until next time, remember to keep on making. Good luck on all your maker endeavors. I'll see you guys next time. Bye, everybody. Bye.